In this video, we are going to discuss Pythagorean theorem and its converse. There are two objectives. The first is you're going to be able to find missing sides of a right triangle using Pythagorean theorem. And the second, you're going to be able to determine whether a triangle is a right triangle using the converse of the Pythagorean theorem. So in this example, or in this first diagram here, we have a right triangle. It says, mark the angle that you think is 90 degrees. This would be your 90-degree angle here. Mark it with that box symbol we talked about all year. Opposite the 90-degree angle is a special side length called a hypotenuse. So if you go across the right angle here, this is your hypotenuse. Now it's special because not only it's crossing the right angle, but it's also always the longest side length. It's always the longest side length. Now the other two side lengths that are connected to the 90-degree angle, here and here, are both called the legs. So this is a leg, and that's a leg. Now what the Pythagorean theorem says is, if a triangle is a right triangle, and A, B, and C are its sides, with C being the longest, or the hypotenuse, then the following relationship holds true. Then A squared plus B squared equals C squared. So for any right triangle, if you have three side lengths, A, B, and C being the hypotenuse, this equation will always hold true. So if we just draw any right triangle, start with a right angle and then connect the two sides, we'll name the legs A and B, and C will be our hypotenuse. And whatever those numbers are, we'll always work out in this relationship as long as it's a right triangle. So, how is it useful? It's useful because you can find missing side lengths within a right triangle. Within the formula there are three variables, and if you are given two of them, then you should be able to solve for the missing variable, much like in any other equation we've solved in algebra so far. The theorem is also useful when right triangles aren't directly involved but can be inserted into the situation. So this could be, for example, a certain type of story problem where there's not a right triangle given, but you can make a right triangle fit into the situation. So here, this example, with the given right triangle, find the length of the hypotenuse, round your answer. So right here across the right angle, you'll see the hypotenuse is empty. Okay, that's our C side length. We do know our two legs though, 8 and 15. We'll call those A and B. Side note, this could be B and this could be A. Those don't matter whatsoever. If you're going to try and find the hypotenuse using the Pythagorean theorem, write your equation down and then simply plug in the known variables. So for example, A is now going to be 8. So instead of A squared, it's going to be 8 squared. B is going to be 15. So instead of B squared, it's going to be 15 squared. C is still unknown, so we're going to leave it as C squared. To solve for C, first do 8 squared plus 15 squared. That's 64 plus 225 equals C squared. When you add those two together, you get 289 equals C squared. Square root both sides. C is going to be equal to 17. And just a reminder, we